Hi everyone, we're doing a lesson today on angles and circles. We'll be looking at one particular rule that associates angles inside semicircles. Right now we've got a starter here, so we can complete that first and then come back for the answers. So question 1, we want to isolate C. Before we can do any of that, so you can see there C is squared, we have to try and get the C term on its own before we can square root. Do not try and square root, or cube root for that matter, until your letter is on its own. So C squared has to be isolated. The first thing we can do is get rid of the 3y. It's plus 3y, so we can take that away from both sides. So we'll end up with 4c squared is equal to m, take away 3y. After that, we can divide by the 4. So c squared is equal to m, take away 3y, all over 4. And now, at this stage, we're able to square root both sides. Square rooting a square gets rid of the square, so we're left with c. Square root the right-hand side, so m minus 3y is underneath the square root, all over 4. For question 2, we have got to find the angle x. In order to do that, we have to find the one beside the 120 first. Now, the 120 is on a straight line with the angle beside it inside the triangle. So 180, take away 120, will give us 60 for that angle down there. Therefore, x is equal to 180, take away 90, take away the 60 inside the triangle. We forget at this stage about the 120. It's not inside the triangle. It doesn't have to get subtracted from our 180 inside the triangle. Therefore, x has to be 30 degrees when we perform those calculations. So, I said we're going to look at angles in circles, and that's really what we're going to do. We're going to be working with right-angled triangles inside circles, and the right-hand side diagram there is working with right-angled triangles, specifically outside circles. We'll touch on that a little bit, but the main thing that we're going to look at is ones like the diagram on the left-hand side. Now, the main thing about these diagrams, there's a couple of things we'll notice from previous investigations with circles. So in this case, we know that AB is known as the diameter. Okay, so we looked at that before when we looked at area and circumference of circles. So AB is the diameter. And in the particular case where we have two lines that meet at either edges of the diameter, so they come from both sides of the diameter, and they meet on the circumference, they actually form a right angle on the circumference there. No matter where the two lines come from, no matter where the two lines meet on the circumference, as long as they come from either side of the diameter, they will make a right angle. So I can make another right angle within this diagram here as well by drawing two straight lines on the other side. There we go. Those two green lines in there will also make a right angle. So two straight lines coming from either side of the diameter meeting on the circumference will make a right angle. Additionally, we have got in the right hand side diagram a radius going from O to P, and that's a radius which again we'll remember from previous investigations into the circle. And on this particular diagram, the line AB is known as a tangent to the circle. Okay, and a tangent means it touches the circle at one particular point. No others, it just glances it and then it goes off again. So, when we have a tangent to the circle that is attached to the radius, or indeed if we wanted to extend that line to the diameter, it could also be attached to the diameter, then it makes a right angle in there as well. So, additionally, if I was to draw another tangent, so I could have a tangent up the top here, it touches the circle on the top left of the circle. If I was to draw a radius then from that bit of the circumference to the centre, then we would have a right angle where those both lines meet. As I say, we'll be focusing on the left-hand side diagram, but the right-hand side diagram will come in as well in a couple of our questions. So let's see how these questions might appear to us and how we could fill them in. So in each of these questions, I want you to fill in all angles contained within the triangle. Okay? When you come to the booklet, you'll have a particular X or A marked onto your diagram. In this case, I just want you to fill in all the angles inside. So we've got an angle 56 and we've got a triangle that matches A, B and C, okay, into a complete triangle. The main thing for these diagrams, and we can't do anything to these diagrams until we realise that at angle C we have got a right angle. Therefore, the only thing left to find is the angle down the bottom left hand side of this triangle. We can do that by doing 180, subtract 90, since our right angle is 90 degrees, subtract 56. Now, without realising that the right angle would be up the top of this triangle, we wouldn't be able to find out the size of the remaining angle at A, which in this case is 34 degrees. Okay, so it's a brief snapshot of different angles inside triangles. This is the only rule that we'll focus on today. So let's look at the next one. This is one of our tangent diagrams. So we've got a tangent along the bottom here. Okay, now since that tangent's always a straight line, we know that on the other side of the tangent there's also a 90 degree angle. 180 take away the 90 that's at angle P has to also give us a 90 on the other side as well. We don't need to consider that, however, we're just looking at the triangle on the right hand side. Now the triangle appears between lines OP, PB and OB. We've got a right angled triangle here. The only angle we are missing is the one down the bottom right. So we know that in here we have a 90 degree, therefore 180, take away what we have in the triangle, which is 90, and 49 will give us the angle at angle B. And again, we can't really do any calculations with this until we have the right angle down the bottom left. In this case, it was given to us. That won't always be the case. You will need to identify it and draw it in like you did with the previous diagram. Okay, so let's look at one more then that is similar to diagram 1. But in this case, we have got two triangles either side of the diameter. So the diameter is down the middle here, along there, okay, of the circle, going right the way through the middle, with the midpoint of the circle in the centre. Take one of these triangles and we'll do our calculations separately. So I'll take the top triangle, the black one here, first of all, and say that that is one triangle. Since the two lines that were black that I've now gone over with red come from either side of the diameter and meet on the circumference, they have to make a right angle. Now it's not letting me pop that in, so I'll just put 90 degrees here at the outside. We know that that has to be a right angle. Therefore, to find the angle down the bottom here, which again it's not letting me right inside it, so I'll just take it outside, we have to do 180, take away 90, take away the 32. Okay, again the key here is spotting that up at that top right side of the triangle we have got a 90 degree angle, and that's the rule that we are using today. So 58 degrees is the angle down at the bottom right hand side of the top triangle. Now the thing is here with these triangles is that they're not related. So down here, down there, we don't have to have a 90 degree angle. Okay, those two angles are random angles based on the two different triangles. They don't have to combine to make a particular angle. They are completely independent of one another. Okay, so let's get rid of these lines around the outside, which it's taking all of those away, well never mind, I'll just go over it, it's fine. That one back, and we'll just use a different colour. So let's go with a purple for the other side. So the bottom triangle here, which I'll go over with purple, is the 2 blue lines and the one in the middle as well. So that diameter line has been used for both triangles. Again, the 2 purple lines that I've drawn over the blue lines, they come from either side of the diameter and they meet on the circumference. So they meet here at a 90-degree right angle. The only angle left to find is the one up the top beside the 32. The only way we can find that is by doing 180, take away 90, take away 53. Okay, and I'm trying to keep the colours the same so they relate to the same triangle, so you can see why I'm using the different numbers as I'm going. So that answer will give us 37 degrees. So the angle up the top there is 37. Now in the diagrams you see today, you will be asked to name or find the size of a particular named angle. So it will be angle A, B, C, angle X, angle Y, whatever it is in the diagram. That's what you're trying to find, okay? It'll be in similar diagrams to this one, similar diagrams to this one here as well. This is what we'll start off with. There'll be a sum of the tangent ones as well, and a few of the ones with 2 triangles within them. Please, when you're doing these questions, just make sure that you take the triangles, if there's 2 of them within the circle, you take them as separate independent triangles. Okay? Let me know how you got on with these questions. Make sure to email me your work, and good luck with them.